The binding of nucleosomes to DNA has a major effect on the binding of gene-specific transcription factors. H3-K56 is located near the DNA entry and exit regions of the nucleosome, and has been reported to increase, when acetylated, the detachment of the DNA from the nucleosome. This helps other transcription factors to obtain access to their binding sites. In the fully atomistic molecular dynamics simulations shown here, acetylated H3-K56 is shown in red, other lysine residues in light green. The simulations show that the acetylated H3-K56 residues remain in their usual position, but lose, of course, their positive charge and therefore no longer contact the phosphodiester backbone of DNA. The acetyl group is hydrophobic and makes extensive contacts with the DNA bases instead. Typical electrostatic interactions between two atoms bearing single opposite charges have an energy of around 1.4 kilocalories per mole. In contrast, energies associated with van der Waals interactions are smaller. Typical interactions contribute from 0.5 to 1.4 kilocalories per mole. We therefore expect a reduction in local binding by around twofold. It is possible that longer simulations will show a more extensive effect, but this is probably unlikely. We need to take into account that other lysine residues, shown in light green here, are not at all affected, and continue to bind at full strength. In the first movie we see acetylated H3-K56 making contact with the minor groove. Looking at the acetylated H3-K56 on the other side of the nucleosome, we see now acetylated H3-K56 contacting DNA through the major groove. In summary, while the acetylation of H3-K56 may facilitate the binding of transcription factors to DNA, we see few, if any, consequences on overall nucleosome structure due to the very localized effect of the post-translational modification.